California's Lake Oroville just sent an impossible warning. Overnight, the water surged 23 feet, with no rain, no upstream releases, and no landslides. Sensors kept rising hour after hour, and engineers raced against time. Millions downstream are now on edge. Something massive is moving beneath the dam, and the next minutes could rewrite the rules of disaster. Last night, Lake Oroville in California experienced a highly unusual event. Sensors recorded the water level rising 23 feet within hours, yet there was no rainfall, no upstream dam releases, and no landslides impacting the reservoir. Engineers and authorities were quick to investigate, as this reservoir is one of the most critical in the state, supplying water and hydroelectric power to millions. At 2:17 a.m. Pacific Time, a telemetry station on the dam's east abutment logged the lake surface at 847.3 feet. By 6:00 a.m., it had climbed to 870.1 feet. Operators had never seen such a rapid increase. Redundant systems and backup gauges confirmed the readings. Field inspections at sunrise verified that the instruments were accurate. The lake was truly rising. Authorities immediately began ruling out possible causes. Doppler radar confirmed clear skies, upstream reservoirs showed stable outflows, and no landslides were detected. Weather stations reported normal temperatures and wind speeds. Even satellite imagery revealed no unusual water inflows. Despite all known triggers being absent, the water continued its rapid ascent. By 8:30 a.m., crews at the shoreline observed that water had shifted more than 60 feet inland. Structures that were normally surrounded by dry ground were partially submerged, and floating buoys no longer matched their surveyed positions. The intake tower, usually exposed, had waves lapping at its base. The situation was unprecedented. Lake Oroville is central to California's State Water Project, the largest publicly built water conveyance system in the world. Its 3.5 million acre-feet of storage supplies water to aqueducts stretching from the Sacramento Valley to Southern California. Over 27 million residents depend on water passing through the reservoir. Additionally, hydroelectric turbines embedded in the dam provide enough power to supply a city of 800,000 residents. The lake's behavior has significant implications. Every unexpected foot of water affects millions of gallons, agricultural water allocations, electricity generation, and community safety. Memories of the 2017 spillway crisis still loom large. During that event, heavy rains forced an emergency spillway release, leading to erosion and a mandatory evacuation for 188,000 residents downstream. The trauma from that incident remains embedded in the region's consciousness. This sudden rise triggered immediate action. The California Department of Water Resources activated its incident command structure. Dam safety teams assembled, and inspection crews were dispatched to every accessible sector. GPS units, sampling equipment, and field measurements were collected to verify the situation. Early analyses of water samples revealed unusual chemical signatures, elevated lithium and boron levels, and trace minerals consistent with deep underground sources. Seismic records also showed a cluster of small microquakes beneath the lake's eastern arm. While minor, these events aligned precisely with the onset of the water surge. Engineers are now considering the possibility that deep aquifers could be feeding water into the reservoir. Simultaneously, sensors within the dam indicated minor anomalies, suggesting that internal movement or seepage may also play a role. Communities along the lake are taking precautionary measures. Residents recalling the 2017 evacuation are staying alert, securing belongings and preparing for potential updates. Authorities are monitoring water levels continuously, ensuring that any necessary emergency measures can be enacted immediately. Environmental teams are also observing the lake's sudden surge. Rapidly rising waters threaten habitats and disrupt normal river flow, potentially affecting fish populations and downstream ecosystems. Water quality measurements are being tracked to ensure safe supply for cities and agriculture. At present, the situation remains under close supervision. Officials emphasize that while the rise is concerning, there is no immediate danger to the public. The anomaly is being investigated thoroughly, with multiple hypotheses under consideration, including subsurface water movement and potential internal dam issues. This event serves as a reminder of the critical importance of infrastructure monitoring and preparedness. Lake Oroville is a lifeline for millions, and even small anomalies can have large consequences. Authorities continue to keep residents informed while working to understand the unusual surge in water levels. Communities, scientists, and engineers alike are watching closely. The situation may stabilize, or it could provide new lessons about California's complex water systems. Either way, Lake Oroville has once again highlighted how vital vigilance and preparedness are when managing critical infrastructure.